Okay, welcome to another 1050 video. In this video we're going to be covering 8.6. We skipped a few. We skipped 8.4 and 8.5 and we're just going straight to 8.6, and this is one of my favorite topics in math. It's very related to something that I really love. I hope you enjoy it too. I guess we'll have to see how it goes. But essentially, this is the last section of new material in our class, and if you'll notice, the homework assignment is pretty short, so I think this will be kind of a nice uh, kind of respite from everything that's been going on. Hopefully this will be a little bit easier than some of the stuff we've been doing before. But what we're going to talk about is, first of all, we're going to talk about something called Pascal's triangle. And I wouldn't say that this stuff is highly related to what we've been doing before in Chapter 8. It's kind of its own thing in a way. Um, it, it can be made to relate to it, but we're not really going to see too much how it relates to sequences. And so Pascal's triangle is a really beautiful thing. And what is it? Well, you start with a 1 in the top position, okay? And then you put 1s below it, so you kind of make a triangle of 1s here. And then what you do is you continue going down by adding consecutive elements of the triangle. So like to get to the position in between these two on the next row, you just add these two 1s and you would get 2. So I would put a 2 there in between those two. If I add 1 and nothing is next to it, I would get a 1. Okay. And then 1 plus nothing over here is also just 1. Okay. And then you do the same thing for the next row. So you do these two added together would give you a 3, right? This would give you a 3. These two added together would give you a 3. This would give you a 1. 1 plus nothing, and then 1 plus nothing over here would also give you a 1. So you'll notice it's kind of a triangle with 1s on the outside, and then you've got some other numbers on the inside, okay? And again, we can keep doing this. 1 plus nothing is 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And 1 plus nothing is 1. Okay? 1 plus, well, we'll do just one more row of this. 1 plus nothing is 1. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 5 and 1. Okay? So you'll notice there's kind of a symmetry going on here of like on either side of the halfway point. It's the same looking on both sides. And this triangle, you can keep going with this, right? But this is called Pascal's triangle, okay? And you may be thinking, why do I care about this? Why is this even a thing? Okay? Well, it turns out this triangle is really helpful when we're trying to expand out powers on binomials. So binomials have two terms in them. So something like x plus some other thing, x plus y to the n power. If we're trying to expand this out, distribute it all out, we wonder kind of what it will look like. Okay? Well, essentially, Pascal's triangle tells us what it will look like. And so what Pascal's triangle does is for this first, you can kind of think of the first row of this, we start at the 0th row. So this is where n equals 0, this top row, okay? Well, when you put a 0 power on it, okay, x plus y to the 0, that's just 1, right? Anything to the 0 power is 1, so that's why there's that 1 there, okay? When n equals 1, that's kind of the next row of your Pascal's triangle, okay? And so what that will mean is, well, x plus y to the 1 power, this is the same as doing just x plus y, right? Anything to the 1 power is itself, and so you can kind of see there's 1x plus 1y, okay? Now, when n equals 2, okay, our next row, that's what that is meaning, and so we're going to be doing x plus y squared, okay? What happens when you do x plus y squared? Well, you have to distribute. You're going to get an x squared and a y squared, right? But you're also going to get an xy and a yx, so in other words, 2xy, okay? And you'll notice what's happening here. Well, this number here is the same as the number in front of the x squared. This number here is the same as the one in front of the xy. And then this number here is the same as in front of the y squared. So the numbers in front of that are in Pascal's triangle actually show up as the coefficients when you expand out your polynomials, okay? Let's look at the cube, okay? X plus y cubed. Well, what this means, this would be the n equals 3 row, okay? So n equals 3 is this row here with 1, 3, 3, 1, right? So what does that mean? It means I start over here at 1, so I'm going to have 1x cubed. It's going to be a cubed because we have a third power on here. So 1x cubed, and then there's a 3 next, so there's going to be 3. You bring down 1 power on the x, so we'd have an x squared, and then increase the power on the y, okay? So there would be an x squared y plus, well, another 3, so 3, and we bring down the power on x again, so x to the 1 power, and then we raise the power on the y, okay? So 3x y squared, and then finally we get 1 times, we bring down the power on the x, so we get rid of the x, and then increase it on y, so plus y cubed, okay? So this is really nice, and if you do this out by hand, if you cube this out and then collect your like terms, you actually get this exact formula, okay? And so Pascal's triangle is a really nice, easy way of, if you're trying to expand a product like this, where you've got a binomial raised to a power, it's a nice way of figuring out what that would be after you distribute it all out, okay? So that's, well, maybe I should do one more, and then we'll do an example in the next video. But let's say we've got x plus y to the 4th power now. Well, now I'm on this row, right? These two. This would be the n equals 4 row. So what do I get here? Well, I start at 1, so I'm going to have 1x to the 4th. Then I bring down my power on the x by 1. We're going to have 4, because that's the next term, x cubed. We bring up the power on the y, okay, x cubed y. Sorry, I'm running out of space. We'll just go to the next line. Plus, the next thing is 6. We bring down the power on the x to x squared. Increase the power on the y, y squared. Plus 4. And then we've got decrease the power on the x, so x, y cubed, okay, and then plus, well, we bring down the power on the x 1 times y to the 4th, okay. So that would be another example. So we'll look at some more examples of doing this in the next video, but essentially Pascal's triangle tells you when you're multiplying something out, how many of each term are you going to have when you multiply it all out, which is pretty cool.